Hello everyone. Today I'm going to go over the college algebra content lines. First of all, um, the major concept in lines is the slope. Line is the straight curve passing through the 2 points, simply identified by at least 2 points. So we define the slope of a line. We use the letter m to be the change in y divided by change in x. And the order is important here. It's kind of like you're moving from left to right. You're looking at the run is the change in x from left to right, and then y and rise is the change in y from that first point to the second point. So if this line kind of like goes up when you look from left to right, that means the slope is positive. If you go from, if it looks like going down, then the slope is negative. You see like you have a run, but the height is simply decreasing, which is the change in y. So that change in y divided by change in x, and the order is important. Once you choose it, it's important. You can swap the points, but once you fix the order, you have to follow that order. Now we have here some examples, like if it goes up, of course, as I said, you're looking from left to right. If it goes up, that's the positive slope, and this is a negative. This is 0 because there's no change in y, so it's like 0 over a number. So the slope of a horizontal line is 0, and the slope of a vertical line is simply undefined, because the change in x is 0, and if you divide any number by 0, that's undefined. So let's go into an example for the slope. Now we have 2 points defined here. As I said, you look at the change in x and y. So that's like, let's identify that as x1, y1, and that's as x2, and then y2. So the slope becomes m equals y2 minus y1 divided by x2 minus x1. So y2 is 5 and y1 is 1 divided by 8 minus 2. So that becomes 4 over 6, which is simply 2/3. And that's the slope of this line. As you see here, it's kind of like your run is 1, 2, 3, 4, 5, 6. So you can just see, just use the red one. So here your run is simply 6. And if you look at the rise from here, it's 1, 2, 3, 4. So that's your rise, which is simply 4. So it's like 4 over 6, which becomes 2/3. So that was like a simple problem to find the slope when the 2 points are given. Now let's move into the equation of a line. So that's kind of like that formula that represents a line. If you know the slope and if you know 1 point, then you can write it as y minus y1 equals m times x minus x1. So you see, it's kind of like you're looking at all the points xy for which the slope becomes m. That's simply what you do. But here x and y are your dependent and independent variables. So x and y stay here. Those are the variables of the equation. X1 and y1 are x1 and y1 are the coordinates of your point, and m is the slope. Now a simple example here, you see the graph is given. You may draw it all the time by looking at the point. See, like this is like your point, which is 1 comma negative 3. Run is 2, and then the rise is negative 1 because you go down here. That's the slope. It's kind of like you look at it in this way. It's like negative 1 over 2. So the top is your rise, which is negative 1. The bottom is simply run, which is 2. So you can always draw it easily. That's like your second point. See, that's like the run and rise, negative 1, and then you can graph it. It's easy to graph. But now if you want to write down the equation, this is like x1 and y1, and that's simply m. So let's just use this formula here. the formula at the top, which is y minus y1 equals m times x minus x1. Let's plot the value. So we have y minus negative 3 equals to negative 1 over 2 times x minus 1. So I simply plug in those values, and as I said, you're keeping x and y. You're writing a formula for it, an equation for it. So we have from here, we have y plus 3 on the left side, and on the right side, if you distribute that negative 1/2, we have negative 1 over 2 times x, and then plus 1 over 2. Now what you are going to do is, usually write it as an equation of y, but you can of course combine x and y's. It's just like here you're simply simplifying it, that's all. So let's subtract 3, and we have these two will cancel, and I have y on the left side. On the right side, I have 1 over 2 times x, and I need to combine these two. So it's like 1 over 2 minus, it's like 3 over 1. That's for 3. So you can multiply the top and the bottom by 2. So it's like 1 over 2 minus 6 over 2, which makes it negative 5 over 2. So that's what we get for here. So minus 5 over 2. This is the equation of the line. So we got the same slope. For the point, you may check it. If you plug in 1, you will get negative 3. And also you can do this calculation here. For this calculation here, you may also use a calculator. That's definitely fine. So we did it on the right side. So I hope this example is clear. Now for the next problem, as you see, it just says try first yourself. So I want you to pause the video now and work on this problem, and then I'm going to show you the solution in after you work it out. So please pause your video and work on this problem. So let's continue with this example. I put the solution here. You may check it with your work now. So this time it asks you to find the equation of the line that passes through these 2 points. It's different than what we solved before, but like a combination. So you first need to find the slope of this line, and then you can use the equation of the line, which is we call this one the point slope form. You can see that at the top of it, it says point slope form because it's given in terms of a point and a slope. I forgot to mention that. So here's the point slope form. You now know the slope. You can use any of the points. I used negative 1 over 2 and negative 1 comma 2, but you can use 3 comma negative 4. Once you simplify, it's going to give you the same equation, and you solve it out like I did in the previous one. So let's continue with the slope intercept form. Actually, we did this in here, slope intercept form. That's like the functional form. And whenever you cover functions, or if you ever seen functions, that's the format that you have, that x is your independent variable, y is your dependent variable, y depends on x. So this form is the one that's used a lot, this y equals mx plus b. I'm sorry, at the bottom, here we go, this form. So that really shows the y-intercept, because if you plug in x equals 0, if you plug in x equals 0, then you will get b as y. So that's like your y-intercept, and then m is the slope. So like a simple problem, slope is 3 and y-intercept is negative 2. So this is your m, and this is your b. So you can write the equation as y equals 3x minus 2. It is that simple, this problem. And the next problem is kind of nice. So this is what we call the general form. So all those x and y's combined into one equation. And sometimes they put this right side 0 and put that one on the, as negative 1 on the left side, but this looks like the general form. So as you can see, to get the point slope form, which gives you the slope and the y-intercept, what you really need to do is you have to solve your equation for y. So that's what we will do in here. We're going to solve it for y. So I add 2x to both sides. See, don't forget, I'm trying to isolate y, which means, I mean, you simply solve for y. They represent the same thing. So so these two will cancel. So I got 3y equals to 2x plus 1. And next, as you can see, I can divide both sides by 3 because I try to isolate y. So I got the final form, which is y equals 2 over 3x plus 1 over 3. So the slope here, m, is 2/3, and the y-intercept b is 1 over 3. So that's the y-intercept, and this is the slope. So I hope this example is clear. So I'm going to next move into the horizontal and the vertical line equations. This is really simple, folks. If you have a point AB, the vertical line passing through AB is x equals a. That means all the x coordinates of the points on this line is simply a. And here the horizontal line will be y equals b in a similar manner. So for example, I put this example here. If you want to find the vertical line through 3, 5, the equation will be x equals 3. Because vertical line means all the x coordinates are same. Okay, and that's 3, so the line is equation x equals 3. And if you look at the horizontal line passing through 8, -2, now you're looking at the line for which the second coordinate is always -2. So that is equation y equals -2. So we put the graph in here. It's so simple, but yeah, you can try yourself with different examples. Like you can write down the equation for the line passing through, let's say like 5, 10, and you can work that out in a similar manner. Now we have the general equation of a line. That's a linear equation. That's the most general form. A, B, not 0. You need the variables. I mean, A and B, one of them can be 0, but both can't be 0. In that case, you get a constant. So in that case, if you have an equation in which the power of x and y is simply 1, and they're written in the linear form, that represents a line. So like a, b constants, ax plus by equals c, or ax plus by plus c equals 0, that represents a line. And every line has an equation of this form. So in the next part, the general equation of a line is given. Actually, I put the graph here, but I'm going to show you how I got that. If this is given to you, folks, I'm going to show you this way. You can do different ways. Like you can find the slope-intercept form and then graph it. You can find 2 points and then you can graph it. But there's an easy way for that for graphing this. You can find the x-intercepts and the y-intercepts. So x-intercept means for a function or for an equation, you set y equals 0. So if you set your y equals 0, I got 2x minus 3 times 0. So that simply disappears. Minus 12 equals 0. So we got 2x equals 12. And that gives us x equals 6. So this is the x-intercept. In a similar manner, if you want to find the y-intercept, let's do it with a different color. If you want to find the y-intercept, this time you set x equals 0. Because y-intercept means x is 0. You're on the y-axis. So we got 2 times 0. So that will simply disappear. That's just 0. Minus 3y minus 12 equals 0. So negative 3y equals 12. You can divide both sides by, negative 3, because we want to find y. So here, y equals negative 4. This is our y-intercept. See, when you graph it, x-intercept is 6, 0. It's right here. That's the point 6 on the x-axis. And the second point is the point on the y-axis, which is negative 4. They write it as an ordered pair, it's just fine. And if you join those 2 points, the line that passing through those 2 points, that is the line that you're looking for. this is how you graph it when the general equation is given to you. I can say there are various ways to do this, but that's something that we didn't cover in the previous examples. So for example, if you solve this for the y variable, then you will find the slope-intercept form, and you can find the intercept as -4 and the slope is kind of that run is 6 and the rise is just 4, so it's going to be 2/3. And in that case, you can graph it as well. But this is just another way to do this. And I hope this example is clear. What I can mention here, just don't forget here, if you look at the slope, that's just rise is 4 and then run is 6, so it's like 4/6, which is 2/3, and the y-intercept as we already find it, which is -4. See, like you can if you solve it for y, you're gonna get this equation: y equals 2/3 times x minus 4. That's the slope-intercept form, and you can use this to graph this line as well. So it's just whichever direction you follow. Now the next one is the parallel lines. So it's kind of like parallel lines, they have the same slope. So for these type of problems, folks, don't forget, whenever you see two lines parallel, they have the same slope. Like for example here, it says find an equation of the line through 5, 2, and then parallel to the line 4x plus 6y plus 5 equals 0. So I have to solve this first for y to get the slope. So I need to find the slope-intercept form. So I can move that 4x and 5 to this side. So 6y will be -4x minus 5. Then I divide both sides by 6. So I divide each term by 6. So I got y equals -2/3 times x and the minus 5/6. I don't really need the y-intercept, but what I need here is the slope. Slope is -2/3. So that's the slope of the line which is parallel to the line that we are looking for. It's kind of like that. So if you look at the required line or desired line, they have the same slope because they're parallel, right? They have the same slope. So the slope needs to be -2/3, and the point will be 5, 2. So this is like x1, y1. So now we can write down the equation. So it's going to be y minus y1 equals the slope times x minus x1, because we have a point. If that was y-intercept, then we can use the point slope form. We got y minus 2 equals -2/3 times x minus 5. That's going to be y minus 2 equals to -2/3 times x plus, I distribute that one over here, it's going to be 10/3. Then I need to add a 2 to both sides. As I said, you can use a calculator to do this calculation here. You're going to add these two, right? But you can do this like as easily by hand as well. This is like 10/3. That's like 2/1. So you need to set the denominators, like make the denominators same. So I got 10/3 plus 6/3, which is going to be 16/3. So if you write it, write the final answer, y equals -2/3x. See, they have the same slope with the given line, and then plus 16/3. So if you plug in 5 here, you're going to get 2. So this is the correct line. And I hope this example is clear. So this is the one for the parallel lines. Now let's go for the perpendicular lines. For the perpendicular lines, it's not really that bad, but it's different. Of course, they don't have the same slope. The slope of one is the negative reciprocal of the other one. So they product the slopes. If you multiply the slopes, you will get -1. For example, if m1 is 4, then for perpendicular lines, m2 needs to be negative 1 over 4. Or for example, m1 equals negative 2 over 5, then m2 needs to be 5 over 2. So you're finding the negative reciprocal or the opposite reciprocal. So that's kind of like, for example, if m1 equals 1 over 3, then m2 should be negative 3. So you multiply them, you get negative 1. So that's the way. Here's the problem that I'm not going to go over here, but just think about it. It's really, once you look at the solution, it will be really simple. But pause the video now and give yourself a couple of minutes to try this problem. So you have a triangle with 3 vertices, and you try to show that this triangle is a right triangle. How can you solve this problem? Let's pause the video and just check that for a couple of minutes. So yeah, probably you thought about like different ways, but folks, the point is this: 3 points, you can draw 3 lines, and if you can show that 2 of them are perpendicular, like slopes of the 2 of them are negative reciprocals of each other, then that means it's a right triangle. So I put the solution in here. So see, like, they look at PR and here PR and QR. One of them has like the lines passing through PQ and then QR. One of them is slope 1 over 4 and the other one is slope negative 4. They are negative reciprocals of each other. If you multiply them, you get negative 1. So that means the line segments PR and QR are perpendicular. So that means this is a right triangle. It's a really nice problem. And they put the graph in here as well. So I have one more problem, and then that's going to be like the end of this portion. So it's similar to what we did before, but this time it says you want the line to be perpendicular to the given line, and it passes through the origin 0, 0. So we solve this one again for y. We did that before, but let's do it again. 6y equals negative 4x minus 5. Then you divide both sides by 6. So these two will cancel. So we got y equals negative 2 over 3 times x minus 5 over 6. And you see the slope becomes, let's say slope 1 becomes negative 2 over 3. So this is the slope of the given line. Now the required line or the desired line has a slope what? Can you guess that? Just pause the video and write this down. So do you have any guesses? I mean, that's going to be negative reciprocal. So the required line should have a slope of 2/3, 3/2, because if you multiply them, you want to get negative 1. It's negative reciprocal of this one, which is going to be 3 over 2, and the point that passes through is 0, 0. So we use that same argument, y minus y1 equals the slope times x minus x1. So it's like y minus 0 equals 3 over 2 times x minus 0. As you see all these zeros, you can simply take them out. And so we got the equation y equals 3 over 2 times x. So that's the line which is perpendicular to the given line, and that passes through the origin. Folks, now I want you to try this problem first yourself. Pause the video and please work on this. That's a good application problem. Please pause the video now and work on this problem. Now as an example, this problem, it gives you the water depth y in the pool after t hours. So when you turn on the hose, I mean, it's given as a linear equation. That's a line, right? The slope is, as you see, 1.5 and the y-intercept is 2. You can clearly see that. But what it really means in terms of the problem, folks, the slope represents what we call the rate of change. So it says, like, for example, if you plug in t equals 1, that means after 1 hour, it's going to increase by 1.5. After 2 hours, it's going to increase by 3. So that 1.5 represents the water depth, the increase of the water depth per hour. So for every hour, if you plug in 4, that means the depth is increased by 6 and becomes 8 in total. And 2 represents the initial depth before the hose is turned on. So that's a good application problem. You may just put this note here. This is this 1.5 here. The slope really represents the rate of change. So we're gonna talk about this in different videos, but that's kind of like the rate at which this function is changing, this y is changing, and this y-intercept is the initial value for that particular model. So it's the initial value is just 2 feet because y is given in terms of feet, and after at each hour the water depth is increasing by 1.5 feet. So I hope you like this video and it's helpful. Thanks for watching. Bye.